This is lesson 4-1 from Thursday, November the 1st. And what we're going to do first, guys, is to kind of remind you of how we've been graphing up to this point by making a table. So just to review, if we choose some input values for x, and then we work those into our function table to get our ordered pairs, you'll see that we can graph these as we go. -1, -5. Zero, -2. And 2, 4. That gives us 3 points on this line, and then we can use a ruler to draw our line. So remember, just like before, if they're asking you to graph a linear equation, they're not just looking for the points, they're looking for that line on your graph. Now, what I'm going to show you is what I think is a much easier, much more efficient way to graph, and we're going to use a form of the equation called slope-intercept form. It's called slope-intercept form because if you have the slope and you have your y-intercept, you can write this equation. So just like always, m is going to stand for our slope. It's still going to be found as the coefficient of x. And now we're going to call our y-intercept b. We've been working with these y-intercepts and initial values throughout our function unit, so now you're going to see that the universal variable for that is going to be b, and it's going to be added to our direct variation equation that we've been using. So let's take a look at how this is going to work. It asks you to use the given information to write an equation that's in slope-intercept form. So all you have to do is take what they give you for m and substitute it in, and take what they give you for b and also substitute it in. Now, we're not going to leave it like that. We're going to simplify this equation to simply read 7x minus 3. Okay? I'm trying to get this a little more clear. Okay, so you wouldn't leave the two signs together. So what's going to happen is whenever your y-intercept is negative, it's going to change that y equals mx plus b to a minus equation. All right, for number 2, again, I'm going to substitute in 3/4 for m, substitute in 6 for b, and there's my equation in slope-intercept form. Now, number 3 is a little different because you can see that your y-intercept is 0. So when you first substitute it in, you're probably going to write this, and then you're going to go, oh, wait a minute, I don't have to write that plus 0 because it's just going to be a direct variation equation. You would know that this would cross at the origin. You would know the y-intercept would be 0. Now, on example 4, if we're just substituting in, you're going to end up with this, and you're going to notice that your slope is 0. So anytime we have a 0 slope, that gets rid of that x term, and it leaves us with a horizontal line, y is equal to 5. That goes along with what we know about a 0 slope line. Now, since we can now write our equations in slope-intercept form, I'm going to show you the method to graph it. And it's so easy. They're just really 2 steps. So once you get your equation into slope-intercept form, you can very easily identify your slope because it's the coefficient of x. And you can identify your y-intercept because it is the constant. Now, remember when we're talking about slope, we're talking about rise over run. So that's going to be 1 up and 2 right, because we know that if it's a positive number with rise, you go up. If it's a positive number with run, you go right. So here's the 2 steps. Graph the y-intercept. That's your first point. So I'm going to go to my y-axis and I'm going to go to 2. There's my y-intercept. Now I'm going to start on my y-intercept and I'm going to go up 1 and over 2. I can do it again if I like, 1 and 2. Now, you can also reverse it. If you need to go the opposite way on your graph, I can go down 1 and to the left 2, and notice that's still on the same line. It's real important if you reverse it that you reverse both directions. Don't just reverse one, or you will change your slope. Okay, pretty easy. Down here at the bottom, highlight this. Always make sure that your equation is in slope-intercept form before you start to graph. All right, let's look at the back. Now here's an example of an equation that's given in standard form, so we can't just start graphing until we get our equation in the correct form. So in order to get y by itself, I'm going to subtract 2x from both sides. I'm going to go ahead and put my x term first, since that's the way slope-intercept form is. So my equation in slope-intercept form looks like this. I can very easily pick out my slope, which is -2, and my y-intercept, which is 3. Now, I like to look at my slope as a fraction because I like to see my rise over run. When you're asked to give the slope, you do give it in simplest form, but for our use in graphing, it's really going to be helpful. I'm going to put it in a think bubble because I'm going to think this. I'm not going to write it, but I'm going to think rise over run. Okay, so I'm going to start with my b, start with my y-intercept, which in this case is 3. Put that point on. And then from my y-intercept, this slope tells me I'm going to go down 2 and to the right 1. I can do it again if I want to. Down 2 to the right 1. Again, if I want to reverse it, up 2 and to the left 1. Now I can draw my line. And that's all there is to it. It's not bad. Much faster than making a table. All right, let's look at these practice problems down here. Again, I have to get it into slope-intercept form, so I'm going to subtract my x from both sides, and that's going to leave me with y equals -x plus 3. So in this case, I have to recognize that my slope is -1 because I have to remember there's a 1 in front of that x. Now, for graphing purposes, I'm going to think about it as -1 over 1. That's going to help me to see my rise over run. I wouldn't write it that way, but I'm thinking it that way. That's my thought bubble. My y-intercept in this equation is +3. So my 2 steps to graphing: graph the y-intercept, then use my rise over run. So down 1 to the right 1, down 1 to the right 1. Okay. Again, I could go up 1 to the left 1 if I wanted to go the reverse direction on my graph. Sometimes you have to do that, like on your homework. If you're running towards the edge of your graph and you don't have room on your paper, you can turn around and come the other way. All right, for number 6, to get y by itself, I'm going to subtract 4. Y equals 4/3 x minus 4. So my slope is 4/3. And my b is -4. So my slope is already in rise over run form, so I don't have to think about it in a different way on this one. My 2 steps to graphing: I start at my b, my -4 on the y, up 4 and to the right 3. And then I draw my line. Now, number 7 is a little more complex equation, but still not bad. We just have to work about getting y by itself. There is a step in this for division that I want you to put a star by, because you might need to look back at this while you're doing your homework tonight. The first thing I want to do is get my 5x to the other side. -2y equals -5x plus 10. Here's what we haven't looked at yet. I still don't have y by itself, so I need to divide both sides by -2. And when I do that, I actually end up dividing all 3 terms by -2. So that leaves me with y is equal to 5/2. I don't want to change that to a mixed number or to a decimal because I want to be able to see my rise over run, but I do go ahead and simplify it to positive. Okay? So my slope is 5/2 and my b is -5. My y-intercept is -5. Okay, so now I'm going to graph it. -5, and I'm going to go up 5 and over 2. There's my other point, and now I can draw my line. Use what you know about if it's a positive slope, you know it's going to be an uphill line. If it's a negative slope, you know it's going to be a downhill line. That will help you kind of check yourself as you graph these linear equations. On your homework tonight, you should have a total of 9 graphs, and we'll take a look at it tomorrow. Make sure you don't have any questions.